Today we're talking about Chapter 6, Section 6, the division of radicals and rationalization. Rationalization. All right. So, see if it's, well, no, let's not put that in there. All right. Excuse me. Still have that cold. Okay, I think all this should get on the first page here. Right. So I got bad news. Division of radicals, again, isn't hard. It's just tedious. And we'll see good examples of that. Alrighty, so simplified form of a radical. We're looking over here at the left side. Uh, so in order to have a simplified form of radical, number one, the radicand has no factor raised to a power greater than or equal to the index, which we've done before. The radicand does not contain a fraction, and no radicals are in the denominator of a fraction. And that's a big deal, and we're going to talk about that uh, at the end of this section. The division property of radicals is kind of falls in line with the same as the multiplication, right? Um, you can either split it up, right, going from the nth root of a over b. Okay, you can split it up like that, or you can um, split it as the nth root of a over the nth root of b. So the nth root of a over b or the nth root of a over the nth root of b. Again, it doesn't matter which way, it works out both ways. Okay, and here's some examples for that. But let's go to some good examples that I would more or less talk through. Okay, so we can this is pretty easy, I think, right? We have the square root of a over 6 divided by b over 4. Okay, so how can I not solve this, but I mean obviously solve it, but explain it. Maybe I should just write it, right? I know that and that I can take that radical off of both the fractions and just put them on fractions individually, or the fraction individually. Okay, and I also know that, I mean, from here, well, the square root of a to the sixth power, well, 6 divided by 2 is 3, so a cubed, and then 4 divided by 2 is 2, so b squared. All right, so I split that up, pretty easy stuff, nothing mind blowing there. B is 3 to the, yeah, okay. So b is the cube root of 81 y to the fifth over x cubed. Well, let's just go ahead and begin the process of splitting this up. So in a previous lecture, I mentioned that it will benefit you to memorize your squares at least to like 10 or 12 or 13 or something like that, and your cubes up to 5. Well, this is one of those cases. Well, kind of. This is not a cube, but this would be a fourth root. So 81 is going to be the fourth root, not the fourth root, uh, is going to be 3 raised to the fourth power. That is what 81 is. And then we have y to the fifth, and that's all over the cube root of x cubed. Well, that's pretty easy. Okay. Well, I can go ahead and let's go ahead and actually fix this over here, right? Let's go ahead and change this 3 to the fourth to a 3 cubed times 3, right? 3 cubed times 3 is indeed the same as 3 to the fourth. So 3 cubed times 3. And then y to the fifth, well, y to the fifth is y cubed times y squared, right? So times y cubed times y squared. Okay, so we did this deliberately because we're going to take out the perfect cubes. Okay, so by taking out the perfect cubes, well, I have the cube root of 3 cubed is 3, the cube root of y cubed is y, and that's going to be on the cube root of, what, 3y squared. And the cube root of x cubed, that's a perfect cube as well, it's just simply an x. Right, so we're just combining a lot of stuff that we've done before into these particular problems. Right, and this time we're going to go a little bit backwards, I guess. We're going to go instead of separating them, we're going to combine them, and that's what we see in this particular example. Right, so we have the fourth root in the numerator and the denominator. All right, well, what if we just made it easier on us, right? Instead, and just wrote the fourth root of 8p to the seventh all over p to the fifth. Okay. By doing this, I can honestly just essentially get rid of that denominator, right? Because p to the seventh over p to the fifth, well, that's just going to be p to the fourth. So we end up with the fourth root of 8p to the fourth, and well, the fourth root of p to the fourth. All right, let's just go and underline it, kind of to uh, keep in line with my first example. We're going to have p on the, that's a good looking p, on the fourth root of 8. Okay. That is a nice looking p. I hope somebody watches this video and also enjoys that. All right, next up we're going to have rationalizing the denominator. Now, I'm going to actually put this on the notes, but it's just going to be on the notes to be on the notes. I'm not going to actually go over it because I don't necessarily think I like the wording of it. Right. Instead, let's do some practices here of rationalizing the denominator before we actually do rationalize the denominator, and I get to that point. So this is just a little guessing game. I'm pretty sure I can put all these right here like this. Alrighty, so well, let's just read the problem. It says fill in the missing radicand to rationalize the radical expressions. Assume all variables represent positive real numbers. Okay. Well, looking at A, the square root of A times the square root of something is equal to the square root of A squared, which is equal to A. Okay. Well, I mean, this should be abundantly obvious to you. Looks like the square root of A times what would be the square root of A would also give me, well, not also give me, but would give me the square root of A squared, right? And that's that. not too hard. The cube root of y times the cube root of something is equal to the cube root of y cubed. Well, y times y squared will give me a y cubed. Okay. And then lastly, we have the fourth root of 2z cubed times the fourth root of something is equal to the fourth root of 2 to the fourth and z to the fourth. Well, it looks like I need to have 2 cubed in there, so it looks like 2 cubed as well as a z, and that would give me the fourth of everything, right? 2 times 2 cubed is 2 to the fourth. Z cubed times z is equals to z to the fourth. Excuse me. Okay, and why do we do this exercise? Well, because when it comes to rationalizing the denominator, and we actually start off with not necessarily a harder one, but let's go to this one first, example 5. Okay, because example 5 is typically the one that everybody really remembers how to do, but example 4 is one that people don't really remember how to do. So let's just jump to example 5 before we do example 4. Alright, so we need to simplify the expression. Okay, well, in order to simplify the expression, I need to make sure I don't have a radical in the denominator. Okay, well, let's see, let's go back to my right here, simplified form. The radicand has no factors. The radicand does not contain a fraction. Okay, so we are violating that second rule with this problem. We have a fraction in the radicand. So let's go ahead and split this up into the square root of y to the fifth over the square root of 7. Okay, well, we're violating another rule here now. We have no radicals are in the denominator of a fraction. Well, we have a radical in the denominator of a fraction. How do we solve this? Well, we need to get rid of that radical. How do we get rid of that radical? Well, it goes back to the problem we did a second ago, right here. We kind of queued ourselves up for this. We need to have the square root of something So looking at a, we have the square root of a times the square root of something is equal to the square root of a squared, which is equal to a, right? And that gets rid of the radical. So what I need to do is I need to multiply this problem by something to get rid of the radical down here. Excuse me, get rid of the radical down here. Okay. Well, how do I get rid of that radical? Well, following along with the previous example, we're just going to multiply this problem by the square root of 7 on the denominator. And then whatever I do to the denominator, I need to do to the numerator. Otherwise, I change the value of my problem totally. Well, doing it this way, I now have the square root of 7y to the 5th in my numerator. And now we have the square root of 7 times the square root of 7. Well, the square root of 7 times square root of 7 is just going to give me 7. Okay, but we're not done because while we did rationalize the denominator, we have a term up here, y to the 5th, that violates, I think, our first rule. Yeah, our first rule here. So the radicand has no factor raised to a power greater than or equal to the index. So we have something raised to a power greater than or equal to the index. With the index is 2, this is raised to the 5th. So I can solve that really quickly. And well, let's actually put this in 2 steps. This will turn into the square root of 7y to the 4th times y. Let's fix this y up a little bit. Over 7. I want to say this 4 didn't even look like it's attached to that y. Yeah, that'll do. And then I can fix this up. So the y to the square root of y fourth is y squared. So we're going to have y squared on the square root of 7y all over 7. And let's actually put that in a box there. Okay. So that's example 5. That's an easy example of it, right? Because I mean, if you have the square root of 7, we'll just multiply it by the square root of 7. If I have the square root of 1,494, then I just take the square root of 1,494. Right, that's the easy one. The hard one is this example 4 that everybody always messes up on. Always. And that's basically a challenge. I'm challenging you to not do this, to not mess up. Okay, so let's just see where we mess up at. Okay, well, we have 5 on the cube root of a. So this is where students mess up. They see the cube root of a down here. Okay, well, if there's the cube root of a, I'm going to go ahead and multiply it by the cube root of a. Okay, notice I'm writing in red. It's wrong. So the numerator becomes 5 on the cube root of a. The denominator will mistakenly, students might put a. All right, we're done. All right, but that's not right, right? Because this is just becomes the cube root of a squared. And we did nothing. We solved nothing. We still have a radical in my denominator. Okay, so instead, again, going back to the example now 2 examples ago, instead what we're going to do is we're going to say, okay, so right here we have an a. We need to get it to an a cubed. Well, how do we get this a into an a cubed? Well, then it must be an a squared, right? So we're going to multiply this by the cube root of a squared. Cube root of a squared. Okay, now we're in business. So the numerator becomes 5 on the cube root of a squared. My denominator now becomes the cube root of a cubed. Perfect. The cube root of a cubed is a. Right. So hopefully that really kind of drove the point home. I don't know. But like I said, that is definitely a problem that every single one of my students always do. Now I will say this. Let me snip this real quick before I get a time. I will say here we're only at 14 minutes. Okay, so this lecture doesn't seem that long, but even then, I've heard that even like YouTube algorithms say that people's attention span don't go any longer than 10 minutes, and honestly, it's shorter than that most of the time, right? It's not any longer than 10 minutes, so honestly, it might be an average of like 3 or 4 minutes. So I will say that you kind of get tired of hearing me talk and things like that. But bad news, you're going to college. You're going to have to listen to somebody speak. More bad news, you plan to go to the workforce, I assume, and you're going to be listening to somebody speak a lot there as well. So just get used to it. Anyways, that's my soapbox moment. I'm sorry. Sorry about that. I try not to veer too far off of math. But anyways, back to math. I went ahead and wrote this as 15 over the cube root of 5 squared times s, right? I know that 25 is 5 squared. And the reason why I went ahead and did this is so I know what I need to multiply this by, okay? Well, I have a cube root in my denominator, so I need to multiply it by, well, how do I turn this 5 squared into a 5 cubed? Well, looks like I need to multiply by 5. How do I turn this s into an s cubed? Well, it looks like I need to multiply by an s squared. My numerator becomes the cube root of 5s squared. And then from here, we have the we have 15 on the cube root of 5s squared. Let's fix up that square a little bit. 5s squared. And then my denominator, perfect. I've got the cube root of 5 cubed, which is 5. The cube root of s cubed, which is s. Okay. And we're not necessarily done because we have that 15 in my numerator and the 5 in my denominator. So I can turn that 15 into a 3. So I've got 3 on the cube root of 5s squared all over s, right? Because the 5 in the denominator got taken away. Let's just go ahead and denote that here. There. All right, and that concludes example 6. I think there's 9 here. Okay. Oh yeah, we have to rationalize the denominator with, again, we're going back to the thing I said on the previous example. I said, hey, you're going to have to memorize the difference of squares. You have got to do it. There's no other way around it. You have to do the difference of squares. And this is an example as such. Okay, so example 7, rationalizing the denominator if we have 2 terms, right? On the previous 3 examples, I think, we only had 1 term in the denominator. Now we're going to have 2 terms. Well, good news, we pretty much know how to do this already. We did it in the previous section. So my problem is we have a 2 plus the square root of 6 all under 2. Right. What I need to do here is I need to multiply by the conjugate, right? Or in other words, I have to turn this into a difference of squares. So this is 2 plus the square root of 6, so I'm going to make it 2 minus the square root of 6. 2 minus the square root of 6. Okay, well, my numerator becomes, let's go ahead and put the equal sign right here, it's equal to, it's going to become 2 times 2 minus the square root of 6. And my my denominator is going to become, that's a negative 2, Sherman. There we go. My denominator is the difference of squares, which is a squared minus b squared. Well, a here is 2, so it's going to be 4 minus b squared. The square b is the square root of 6. The square root of 6 squared is 6, so 4 minus 6, or in other words, negative 2. So negative 2. And then it looks like the negative 2's are going to cancel out here. Bam, bam. So we end up with just a 2 minus the square root of 6. Right? Pretty easy, but it does get harder and more tedious from there. This is basically the same example. We just got the FOIL and the numerator. Instead, we're going to work on this one, right? The harder one. This one is absolutely ridiculous. And again, example 8 is basically this, but easier. So if we need to rationalize, oh man, this is going to be a couple pager here. So real quickly, let's go ahead and rewrite this problem. 3 on the square root of 2 plus 2 on the square root of 5. Oh yeah, this is going to be awful. And we've got the square root of 2 minus 4 on the square root of 5. All right. Stop that. I don't know if y'all can hear my cat or not. 2017. Let me write that down. I want to see if y'all can hear. Okay. All right, anyways, I need to rationalize the denominator, so all I have to really do is multiply by the conjugate. So we're going to have the square root of 2 plus 4 on the square root of 5. We're going to multiply that by the numerator as well. Okay, and this is going to be very tedious. All right, so here we go. Well, the denominator is going to be pretty easy, right? So realistically, the focus is going to be on the numerator. And real quick, let's just go ahead and do the denominator and just put it off to the side here. Okay, so this is a, this is b. It's going to be a squared minus b squared, right? So the denominator is going to be the square root of 2 squared is going to be 2. And then again, it's a squared minus b squared, so it's going to be 2. And then where it's going to be minus b squared, so it'd be 16 times 16 times 5, which is 32, 64, which is 80. So 2 minus 80, or in other words, 78. Okay, so my denominator is going to be 78. Again, just doing the difference of squares. So switch for my denominator here at 78, just denoting it. And now we're going to focus on this. This is going to suck. Okay, so let's go ahead and write that. Let's see, let's put that in, let's do it in yellow. Okay, so again, just imagine we've got, that we have these foiled like this, right? That we have parentheses like this, because that's essentially what it is, right? And I'll just keep it like that, actually. So 3 on the square root of 2 times the square root of 2, well, that would become 3 on the square root of 2 times the square root of 2 is 2, so 3 times 2. Let's just keep it as 3 times 2 for now. And then we have this. We have 12 on the square root of 10, so plus 12 on the square root of 10. Right. And then we have this, so we have 2 on the square root of 10, so that's looking good. So plus 2 on the square root of 10. And then here we have 8 on the square root of 5 squared, so 8 times 5 is 40, so plus 40. This actually doesn't seem as bad as I thought it would be. Okay, well 3 times 2, let's just go ahead and fix this up right here. 3 times 2 is 6, so we have 6. So let's combine like terms here, so we're going to end up with a 46, right? A 6 and a 40, plus, looks like the 12 and the 2 and the square root of 10, they have a like term, so it's going to end up being, 14 on the square root of 10, and all that over 78, which we said over here, so let's go ahead and erase that. All right, looks like we can fix this up just a little bit. Everything, it looks like, I mean, everything is an even number, so this is pretty good. So it looks like, let's see, it looks like I can pull a 2 out of my numerator, so I'm pretty sure nothing else. So 2 out of my numerator, and that becomes, well, we have a 23 plus 7 on the square root of 10 all over, and, well, we can keep the 78, kind of, I guess, right? 78, and let's actually snip this, and all right, so this is going to be a lot of pages. I think we'll just have 2 pages, so that's not bad. So we do this, and we see that this 2 and this 78 cancel. 78 turns into a 39. So I think that's it. I don't think I can simplify this anymore. So this turns into 23 plus 7 on the square root of 10 all over 39. That wasn't terrible. All right, well, that does conclude today's lecture.